So in this video, we're going to look at the greatest and least values of a function within a closed interval. So for each graph below, the maximum and minimum values within a closed interval are given. So between -2 and 1 in the first curve, which we're going to highlight now, you can see that the minimum value is -3 and the maximum value is 0. For our second curve, we want to consider x values between -1 and 3. So you can see in this example, our maximum and minimum values are at each end of our interval, the minimum value being -7 and our maximum value being 18. In our third curve, we want to consider our x values between -2 and 4. And so our minimum value is at -2, -12, and our maximum value is at 4, 48. So in closed intervals, the maximum and minimum values of a function are at a stationary point or at an end point of the interval. So the procedure is to evaluate the endpoints, differentiate the function, make it equal to 0 and solve to find the stationary points, and then we can find the maximum or minimum values of those stationary points by substitution, and then we're going to compare the value of the endpoints to the stationary points and state the maximum and minimum values of our closed interval. So in this example, we want to find the maximum and minimum values of the function of x equals 4x cubed minus x squared minus 4x plus 1 in the closed interval where x is greater than or equal to -1 and less than or equal to 2. So the first thing we want to do is evaluate the endpoints. So we want to substitute in x equals -1 and x equals 2. So if we evaluate f of -1, we get 4 multiplied by -1 cubed minus -1 squared minus 4 times -1 plus 1. And that means that f of -1 is going to have a value of 0. And then we're going to evaluate f of 2, and so that's 4 multiplied by 2 cubed minus 2 squared minus 4 times 2 plus 1, and so f of 2 is going to have a value of 21. Now we need to consider our stationary points, so we need to differentiate our function. So our function f of x equals 4x cubed minus x squared minus 4x plus 1, and if we find the derivative with respect to x, we're going to get 12x squared minus 2x minus 4, and we make that equal to 0 because the gradient at stationary points is 0. We can factorize that, taking out a common 2 to get 6x squared minus x minus 2 equals 0, and we can divide both sides by 2 to eliminate the 2 in front of the bracket, and then we can factorize the bracket. Our magic number is -12, and our factors that are going to add together will be -4 and 3. We can substitute them back in, so we've got 6x squared minus 4x plus 3x minus 2 equals 0. We're going to factorize the first two parts of that expression with a factor of 2x upon 3x minus 2 plus 1 upon 3x minus 2 to have that duplicate bracket. So our brackets are 2x plus 1 upon 3x minus 2 equals 0. So that means that we've got a stationary point when 2x plus 1 equals 0. So that gives us a value of x equals -1/2. And we've got a stationary point when 3x minus 2 equals 0, giving us a stationary point at x equals 2/3. So we need to work out the coordinates of these stationary points in order to work out what the maximum or minimum value is. So we've got our stationary points at x equals -1/2 or x equals 2/3. And we need to substitute these into our original function to work out what the y coordinate would be. And so f of x was 4x cubed minus x squared minus 4x plus 1. So if we evaluate f of -1/2, we're going to get 4 multiplied by -1/2 cubed minus -1/2 squared minus 4 times negative a half plus 1. And that's going to give us a value of f of negative a half of 9/4. And then we want to find f of 2/3. And we're going to substitute that in. 4 times 2/3 cubed minus 2/3 squared minus 4 times 2/3 plus 1. And that gives us a value of f of 2/3 of negative 25/27. So now that we've evaluated our endpoints and our stationary points, we need to compare them. So we had a point at -1, 0, and then we had negative a half, 9/4. Then we had a stationary point at 2/3, negative 25/27, and the end of our interval was at 221. So you can see that our minimum value is one of our stationary points, and that was when x equaled 2/3. So our minimum value is negative 25/27 for this function. And the maximum value of this function was actually at the end of our closed interval when x equaled 2. So our maximum value for this function is 21.